sometimes that's not that obvious. And then you need to say if this minimum principal stress is going towards the east, or is going towards the north, or a combination of that. This is going to be an axis that we're going to call depth. And this is east, and this is north. So you need to know those directions in order to characterize the horizontal stress. So, yes, sir?
On this diagram, could you show how the balloon would shape?
In this case,
Yes.
it would be, it would depend on which one is the largest of these. And we're going into that right now. So, in the previous case, let me get to there. I'm assuming that SH mean is smaller, of course, than SH max, and that's smaller than SV. That's why the shape of the balloon is like that. Let me ask you the following. Are the horizontal stresses always going to be smaller than the vertical stress?
No.
Why not?
It can be in water, and all of the forces in all directions are equal.
Okay, you're getting into an isotropic state of stress. Yeah, I think, but that's not exactly the answer I'm looking for. Why not?
It's a depth.
And what's
Greater
depth going to
depths,
do?
The overburden stress is going to be greater. So it could overcome a horizontal maximum stress at some point.
No, but you're saying that overburden is always going to increase, right? But I'm asking if there's going to be a case in which these horizontal stress are going to overcome the overburden. Do you think about any reason for that?
Are there faults?
Faults, you're getting closer, yeah?
Didn't we say that SB could change throughout, like it could get smaller, so you couldn't?
No,
like
that was pore pressure.
Yeah, but the difference.
If you
That's
small.
Yeah, that's sigma V. Sigma V can change. But not the total stress. The overburden, it will always increase with depth. Always you're going to have to more weight and weight. Okay, let me tell you the answer. Actually, many times our objective is to determine these stresses. In many cases, let me write here. Let me copy exactly the drawing I have in mind. My notes. This is the maximum principal stress. This is the intermediate principal stress. And this is the minimum principal stress. I'm going to call a place in which the maximum principal stress is SV, the intermediate principal stress is SH max, and the minimum principal stress is SH mean. It's something that we call normal faulting stress regime. Example of this type of normal faulting, Permian Basin, Eagle Ford, Barnett. Actually, most of the very highly producing hydrocarbon producing basins in the US are under normal faulting type of regime. In this normal faulting type of regime, let me do it here small. This is depth. We'll have always SV, and then we'll have SH mean, and in the middle is going to be SH max. Let me go to the totally opposite case, which is called a reverse or a thrust faulting stress regime. This is a case when the tectonic plates push so hard in the lateral direction. You guys probably are familiar, remember about convergent plates, divergent plates, transform boundaries, which go in this way. But when they converge, they push a lot in lateral direction so that you have a lot of compression in horizontal direction. And when that's the case, your horizontal stresses can be actually larger than the vertical stress. And examples of these kinds of kind of reverse faulting regime for hydrocarbon producing basins, it's, for example, now in one of the most prolific shales under this, not everywhere, but in some sections, some depths. It's in Argentina. It's called Vaca Muerta Shale. In many reservoirs in Australia, also, you have reverse faulting. And in this case, your maximum principal stress is horizontal, and your minimum principal stress is actually vertical. In this place, both of the horizontal stresses are actually larger than the vertical stress. And there is going to be one intermediate case, which is going to be called strike slip. Probably this might not make a lot of sense to you right now, but we're going to see where that name comes from. And in this case, your maximum principal stress is going to be horizontal, your intermediate principal stress is going to be vertical, and your minimum principal stress is going to be, again, horizontal. And example of these strike slip are some reservoirs in California. You see in California with all the sierras and all of that, state of stress quite messed up. So there you can see horizontal stresses which are larger than the vertical stress. Another name for this one, normal faulting, is also, probably you're gonna remember, it's called extensional regime. And it's called extensional because that means that there is one direction which is horizontal in which the basin is extending. In the direction in which it is extending, the stresses are the minimum, the lowest. So, yes, sir.
Is there a depth where that's no longer true because of intense pressure from the older version?
Some of these stress regimes do change with depth. And they are linked to the history of the basin. And we're going to see later in an exercise, they're also linked to the properties of the rock. If you are compressing a rock which is very stiff, that will tend to create more stress in horizontal direction than a rock which is very soft. So it does change with depth as well. It changes with location, it changes with depth. Very quickly, let me show this and motivate the next thing I'm going to say. If we go over here, and that's what I wanted to say next. Where is that? There. Okay. Let's see what's over here. Okay, yeah, this is what I wanted to show. Here you see a map that tells you what is the direction of maximum horizontal stress in the world. So that direction of maximum horizontal stress, and whether if you are in a normal faulting regime, strike slip, or thrust regime, it depends on where you are. Closer to big mountains, you get to compressional. Further away, in more passive basins, you get into extension. It depends on where you are, and also it depends on depth. So, let's go now here back to Texas. I'm going to do my best here to make a schematic of the state of Texas, which always gives me a lot of trouble. Something like this, that. Okay, not too bad. Yeah. So, what shale do we have close to Dallas-Fort Worth? Barnett shale. In the Barnett shale, close to the Barnett shale, we have, let me draw a little bit over here. We have a normal faulting regime. Moreover, we know that the maximum horizontal stress is in this direction. And something I didn't say, but I say now, always this maximum horizontal stress and minimum horizontal stress are going to be perpendicular to each other. And those two are also perpendicular to the vertical stress. Because we have the maximum horizontal stress in this direction, you will expect that in this direction, now we have the minimum horizontal stress, right? And because it's normal faulting, SV is larger than SH max, is larger than SH mean, and SV is in the direction of the perpendicular to this plane. Okay, here is the question. Question number 1. What is going to be the direction of hydraulic fractures at that location?
Perpendicular to SH min. So that's going to be north.
So are they going to be planes like this page, like that?
Northeast.
Like a pancake? No, right? It's going to be vertical. So is it going to be a plane? You tell me stop, okay? It's going to be like this, or
Like that?
Yes.
right there, right?
Yeah.
Those are going to be the hydraulic fractures. And one more thing, based on that, what would be the direction of your horizontal wellbores?
Parallel to SH min.
If you want to do multi-stage hydraulic fracture.
Parallel to SH min.
Parallel to SH mean, right? And moreover, you may want to drill, give me one sec, guys. These are going to be your hydraulic fractures. And you may want to drill a wellbore, which is horizontal, and it links those. So that will be your horizontal wellbore, and it will go in the direction of SH mean. Just with knowing this, you know 80% of geomechanics. Okay? Now we're going to get into details about how to make those fractures, how to measure this direction, spacing, a little bit of math to put all this together, but I would say this is 80% of what you have to do. All right? Okay, guys, I'll see you on Friday. Start working on the homework. Everything is online, so you can get started. We'll discuss the problems here on Friday. All right? See you on Friday. Yeah.
Is it due on Friday?
No, it's